So we've talked about the TCP/IP address and the subnet mask. Now those are the only two parameters that you have to fill in for basic communication. So let's go through our first scenario, and we'll keep going until we're stuck, and then we'll fill in the next parameter that you have to do. Okay, so we've got me wanting to communicate with server 1. So I bring up a command prompt and I type ping space 192.168.100.51. Now the first thing that I'm going to do is I'm going to look at my own subnet mask, and I'm going to determine, based on my subnet mask, what is my breakout between network and host. Okay, I'm going to determine that I'm on the 192.168.100 network. Now if the host that I'm trying to communicate with is also on the 192.168.100 network, then I can communicate with him directly. I don't have to go through any routers. So I look at the IP address that I'm going to, and I see that it is also 192.168.100. So server 1 is on my network segment. And so now I can communicate with him directly. So the next thing that happens is I send out an ARP broadcast, ARP, Address Resolution Protocol. What the ARP broadcast does is sends out a shout to the wire saying, whoever is 192.168.100.51, give me your MAC address. A MAC address is a Media Access Control address. It's the address that's actually burned into that network card. It's the only way that we can definitely be sure that this is exactly the host we're trying to communicate with. An IP address, software configurable, we can change that. The MAC address, burned in, can't change that. Quick intermission here. The MAC address, the place that comes from, each manufacturer of network interfaces, network cards, is assigned the first half of the MAC address that is going to be specific to that company. The second half of the MAC address, it's their responsibility to make sure that all of their MAC addresses are unique. Okay, so I send out the ARP broadcast. I find out what his MAC address is. I communicate MAC address to MAC address. I get my ping. Okay, now let's say that I want to communicate with server 2. Okay, so I type in ping space 192.168.102.115. First thing I do is I look at my subnet mask, and I determine, based on my subnet mask, that my network is 192.168.100. So now I look at the IP address of the host I'm trying to communicate with, and I see that he is 192.168.102. So he's not on my network. So now what I need to do is send my traffic straight to the default gateway. Okay, now we find that we're stuck. So the third parameter we're going to talk about is a default gateway. Now what a default gateway is the address of the port on the router that's your ticket out. Okay, it's the address of the door in the room. Okay, so if I can't find you in the room, well, then I'm going to need to go to the door to find you, because you're going to be out there somewhere. So it's the ticket out. So in our case, what is our default gateway going to be? 192.168.100.1. The standard for assigning interfaces to routers is typically to use the .1 address for the router interface. And so I configure my machine to use 192.168.100.1 as my default gateway. Now once I have configured it to have a default gateway, now I can communicate with server 2. So I type ping space 192.168.102.15. I examine my own subnet mask. I determine that my network, based on my subnet mask, is 192.168.100. I look at the IP address I'm trying to communicate with. I determine that's not on my network. I can't just send out an ARP and hit him. I have to go to the default gateway. So my traffic gets sent to the default gateway. At the default gateway, the router is going to look at his route table, And he's going to determine based on this route table that you need to use this interface to get to the 192.168.102 network. So now the traffic is sent to this segment, and now the ARP broadcast can be sent out. So shouts out to the wire for IP address 192.168.102.15, what is the MAC address? Okay, he responds because he is .102.15, says this is my MAC address, and that MAC address gets sent back to me. Now I can communicate MAC address to MAC address. Okay, now let's talk about what is actually happening under the covers for this particular scenario. Now, I try to communicate, I determine he's not on my network, and so I go to the default gateway, yes, but the actual method of my communication with that default gateway is I do send out an ARP on my local segment. It's just that once I determine that he's not on my local segment, now the ARP is for my default gateway. So I ARP for the default gateway to communicate with the default gateway so that I can, send my packet, so I can do my communication. He's still going to read his route table. The packet is still going to be sent over here and ARPed on this local segment. So what's really happening is, as you communicate router to router to router, every step along the way, the ARP is going to be for the next destination, the next endpoint along that journey. Okay, so what do we know so far? We know that our subnet mask is going to determine which network that we are on. We know that broadcasts are not going to make it through a router. Let's go through an example of how we can make it so that we can't communicate based on having the wrong subnet mask. IP addresses are fine, every component is working, but the subnet mask is set incorrectly. Okay, so let's say that instead of 255.255.255.0, we set it to the subnet mask we talked about earlier, 255.255.0.0. So with that subnet mask, when I try to communicate, what is my network going to be identified as? Well, the answer is, I am now on the 192.168 network. Okay, so now let's try to communicate with server 2. So I type ping space 192.168.102.15. First thing I do is I look at my subnet mask. I determine I'm on the 192.168 network. Well, my destination is also on the 192.168 network. And so will I go to the default gateway? The answer is no. I'm going to send out my ARP on my local segment because I'm assuming that he is on the same segment as me. He has the same network address, therefore he must be within the same segment. So my ARP is sent here for server 2. Broadcast can't get through the router. The packet never makes it to server 2. We're not communicating. We talked about the different parameters that you have to communicate on a TCP/IP network. We talked about when the default gateway comes into play. We talked about using that ARP broadcast to finish the cycle to ultimately get that MAC address and enable that communication. Now let's go through an on-screen demonstration and see where these parameters are set, and we'll take a look at the ARP cache.